In this video, we will show you how to get started with the SAM D21 Curiosity Nano Evaluation Kit using MPLAB Harmony version 3. If you are new to Harmony version 3, be sure to watch our video, How to Set Up the Tools Required to Get Started with Harmony version 3. This project is based on the SAM D21, our Cortex M0 Plus microcontroller. For this video, we will use the SAM D21 Curiosity Nano Evaluation Kit that contains the SAM D21G17D microcontroller. Let us look at the resources available on the board before we get started. The SAM D21 contains a user LED, which will be useful to show the application status. There's a user switch to read the user inputs, a micro USB connector to connect with a PC, and an onboard Nano debugger for programming and debugging the SAM D21G17D MCU. This onboard debugger acts as a virtual COM port. Users can extend the SAM D21C Nano board using the Curiosity Nano base for clickboards. This will help the hardware extension platform to ease the connection between Curiosity Nano kits and extension boards like the Microbus click modules and Explained Pro extension boards. To get started developing applications on this board, open the SAM D21 Curiosity Nano Evaluation Kit webpage and download the Getting Started demo project. The SAM D21N Getting Started zip file has the demo firmware, and you can extract it from there. Open the project in MPLAB XIDE. Go to Tools, Embedded, and open the Harmony 3 configurator. The project graph is opened. You can see the various peripherals configured for the SAM D21 MCU under this demo project. Clicking on the peripheral block shows you the configuration done for that peripheral. By clicking on SIRCOM 5, you can see the SIRCOM 5 configured as USART. By clicking on the real-time clock, or RTC peripheral library, you can see the RTC configuration to generate a 500 milliseconds timeout interrupt. By clicking on the External Interrupt Controller, or EIC peripheral library, you can see the EIC configuration to read the switch SW0 status change. In the same way, you can see the configurations for other peripherals in this Configuration Operations window. To configure other necessary system-specific configurations like a clock, DMA, or event systems, go to the Tools menu and choose the system module you would like to configure. For example, to configure the clock, open the Clock EasyView window by clicking Tools, then Clock Configuration. Here you will see the main clock is set to its default clock frequency of 48 MHz. Using this Harmony configurator, you can easily add another peripheral, reconfigure the project, and generate the code. You can go to the project configuration path and check the various files to understand the implementation of the project. This code sends the strings using USART on a periodic basis, and the periodic timeout can be changed by the switch press. To run this demo project, connect a micro USB cable between the debug USB on the board and the PC. This enables the programming of the microcontroller and provides a serial connection with the console device. In MPLAB XIDE, under Project Properties, select SAM D21 Curiosity Nano as the target kit in the Connected Hardware Tool dropdown, and then click OK. Open a terminal application such as TerraTerm on the PC and perform the serial port setup. You can now build your project and program the SAM D21 Curiosity Nano Evaluation Kit by using MPLAB XIDE. Here you can see the LED toggling rate text printed on the console in a periodic basis. The periodicity of the timeout will change from 500 milliseconds to 1 second, 2 seconds, 4 seconds, and back to 500 milliseconds every time you press the switch SW0 on the SAM D21 Curiosity Nano Evaluation Kit. The demo project shown in this video is also available on GitHub. Go to the link shown here to open the MPLAB Harmony Reference Apps repository. The demo examples on the SAM D21 Curiosity Nano Evaluation Kit are available under the path shown here. There are also some collaterals available in the web link shown here, which are related to this video content. In the link provided below, you could refer to this video for step-by-step instructions on how to create a demo project on SAM D21-based MCUs using MPLAB Harmony. And finally, this is our MPLAB Harmony landing page, where you can find all the information about Harmony version 3. Thanks for watching.